Okay, so get ready because today we're diving deep into the Big Bang.
Sounds exciting.
Yeah, we've got this video. It's called The Beginning of Time, The Big Bang Theory. And well, it's full of these crazy ideas.
Oh, I bet. I love this stuff.
Like, think about this. The whole universe, like everything, squeezed into something smaller than an atom.
Yeah, the singularity. It's wild,
It
right?
is. And then, boom, faster than light expansion,
Cosmic inflation.
cosmic inflation. And get this, we can still detect the faint heat from that first moment.
The cosmic microwave background radiation, it's like a whisper from the very beginning of time.
Mind-blowing, right?
Mm.
So let's start with the singularity. Imagine everything, I mean everything, squeezed into a space so small, it's almost impossible to picture.
It's hard to even grasp. Yeah, a point of just unimaginable density and heat. Our current laws of physics just can't handle it.
It's like the ultimate before picture, right?
Yeah.
But how can we even begin to make sense of something so extreme?
Well, that's where the Big Bang Theory comes in. And it wasn't really an explosion like we usually picture it.
Not an explosion.
No, it was more like an incredibly rapid expansion of space itself. We call it cosmic inflation.
So not an explosion, but everything inflating super fast. Like going from subatomic to bigger than a galaxy in the blink of an eye.
Exactly. Like in less than a blink, the universe just grew, like unbelievably fast. And here's the kicker. Faster than the speed of light.
Wait, what? Faster than light? But isn't that like the ultimate speed limit? How is that possible?
Right, it sounds crazy, but it doesn't actually break any laws of physics. See, Einstein's theory of relativity says nothing can travel through space faster than light, but cosmic inflation is about space itself expanding, and there's no speed limit on that.
Oh, okay. So it's not things moving super fast through space, but space itself stretching at an incredible rate.
Exactly. It's like,
I'm still trying to wrap my head around that.
it takes some getting used to.
It does. But how can we be sure that any of this really happened? It sounds, I don't know, almost too fantastical.
Well, that's where the evidence comes in. And one of the most compelling pieces is the cosmic microwave background radiation, or CMB. It's like a faint afterglow of the Big Bang.
Wow, so we can actually detect this ancient heat. It's like looking back in time to the very beginning.
Precisely. And telescopes, like the Planck Observatory, have actually mapped this radiation, giving us a kind of baby picture of the universe.
Baby picture of the universe.
Yeah. And the amazing thing is that the CMB isn't just random. The patterns in it tell us a lot about the early universe and really support the idea of cosmic inflation.
Okay, so we've got this incredible expansion. The universe is cooling down. What happens next?
Well, as things cool down, they start to settle a bit. Imagine this chaotic sea of energy gradually transforming into something more organized.
Well, organized. What do you mean by that?
Well, think about it like this. In the singularity, everything was all jumbled together, a kind of primordial soup. But as the universe cools, the fundamental forces of nature, gravity, electromagnetism, and the others, they start to separate out.
So instead of everything being mixed up, these forces start becoming distinct.
Exactly. And that's a huge deal because once these forces are differentiated, they allow particles to form and interact in completely new ways, like protons, neutrons, electrons, the building blocks of everything.
So we're going from pure energy to matter starting to appear.
Right. And eventually, these particles combine to form the first atoms. That process is called nucleosynthesis, and that's how hydrogen and helium, the very first elements, were created.
Wow. So we've got the building blocks,
Yeah.
but we're still a long way from the universe we know today.
A very long way.
If you had to describe it, what did this early universe actually look like?
Honestly, pretty bleak. No twinkling stars, no swirling galaxies, just a vast, dark expanse of hydrogen and helium gas. We call it the cosmic dark ages.
The cosmic dark ages. Sounds a bit gloomy.
Yeah, it was a dark time, literally. But this darkness lasted for a surprisingly long time, about 200 million years. And then something incredible happened.
What happened?
The first stars began to ignite.
Ah, finally some light.
Exactly. And these weren't just ordinary stars. These were colossal giants, incredibly hot and bright. Their radiation basically flooded the universe, tearing apart those simple hydrogen and helium atoms and clearing the cosmic fog. And that marked the end of the Dark Ages.
So this is where the universe started to look a little more like what we're familiar with. Stars and galaxies starting to form.
Precisely. The first stars were like the pioneers, paving the way for the formation of galaxies and everything else we see today. But remember, we talked about the universe expanding. Well, that didn't just stop after the Big Bang. In fact, it's still happening.
The universe is still growing. That's almost impossible to imagine.
I know, right? But how do we even know that's happening? Well, it has to do with observations of distant galaxies and something called redshift.
The redshift, what's that?
Well, think of it like the Doppler effect, but with light.
Like when a siren changes pitch as it moves toward or away from you?
Exactly. As light from distant galaxies travels through the expanding universe, its wavelengths get stretched out, shifting towards the red end of the spectrum. And by measuring this redshift, we can actually figure out how fast a galaxy is moving away from us.
So by looking at the light from these galaxies, we can see how fast they're moving away. And I guess the farther away the galaxy, the faster it's moving.
Exactly. And these observations led to a pretty surprising discovery.
Mhm.
The universe isn't just expanding, it's actually expanding at an accelerating rate.
It's getting faster. So there's something pushing everything apart.
That's what we think. Scientists call it dark energy.
Dark energy. That sounds kind of ominous.
It's one of the biggest mysteries in cosmology. We know it's there because we can see its effects, but we have no idea what it actually is.
So we've gone from a tiny singularity to this vast, expanding universe filled with stars and galaxies, and it's all being driven by this mysterious force we don't even understand. It's a pretty amazing story. But I have to ask, what about before the Big Bang? What happened before that initial expansion?
Ah, that's the million-dollar question, isn't it? The Big Bang Theory does an amazing job of explaining what happened after the singularity, but it doesn't tell us what caused it or if anything existed before.
So are there any theories about what might have come before? What are some of the ideas scientists are exploring?
There are some pretty mind-blowing ideas out there, like the idea of a multiverse, where our universe is just one of many, maybe even an infinite number, all existing at the same time.
Oh, multiple universes. That sounds like something straight out of science fiction. But are there any scientific reasons to think that might be true?
It might sound far-fetched, but there are actually several different versions of the multiverse theory that come from different areas of physics. The basic idea is that these universes could have different physical laws, different constants, different dimensions, you name it.
So like in another universe, gravity might work differently or the speed of light could be slower?
Yeah, it's almost impossible to even imagine. And some physicists even think these universes could interact with each other, maybe even collide or give birth to new universes.
So our Big Bang could have been caused by a collision with another universe. That's incredible.
It's a wild idea. And it's one that could maybe even explain some of the things we see in our own universe, like the patterns in the cosmic microwave background radiation.
It's mind-boggling to think that everything we know, everything we can see, might just be one tiny bubble in a sea of other universes. But what about other ideas? Are there any other theories about what might have come before the Big Bang?
Well, there's another pretty interesting idea called the cyclical universe. In this model, the Big Bang wasn't a one-time event, but just the start of a new cycle and an endless series of expansions and contractions.
So it's like a cosmic heartbeat with no beginning and no end.
Yeah. The Big Bang leads to expansion, like what we're seeing now, but eventually things slow down, reverse, and then everything collapses back in on itself in what some call the Big Crunch.
And then another Big Bang kicks off a new cycle.
That's the idea. The universe just keeps going through these endless cycles of expansion and contraction.
It really makes you question our idea of time, doesn't it? Instead of moving in a straight line, maybe it's a circle, repeating itself over and over again.
Definitely something to ponder. But, we've covered a lot of ground already. From a tiny singularity to this vast, expanding universe shaped by forces we can't even see, and now these mind-blowing ideas of multiverses and cyclical time.
It's amazing to think about.
It is. And you know what I love about cosmology? The more we learn, the more we realize just how much we still don't know.
That's what makes it so exciting.
Exactly. There are so many mysteries still out there waiting to be solved. Who knows what incredible discoveries are just around the corner? Thinking back to cosmic inflation, that period right after the Big Bang, it's just incredible. The universe expanding faster than light. How does that even work?
I know, it's mind-boggling. For the longest time, scientists thought it broke the rules of Einstein's theory of relativity. Nothing can travel faster than light.
Yeah, that cosmic speed limit. But here's the thing. Cosmic inflation doesn't actually violate that rule. It's not things moving through space faster than light. It's space itself that's expanding, and that doesn't have a speed limit.
So it's not like things are zipping around at super speeds. It's more like space itself is stretching and growing at an insane rate.
Exactly. Think of it like a balloon with dots on it. As the balloon inflates, The dots move apart, but they're not actually moving across the surface. The surface itself is expanding.
Ah, I see. So galaxies are like the dots, getting farther apart as the universe expands.
Exactly. It's a good way to visualize it, right? And it's amazing to think that this tiny little period of inflation, like a fraction of a second, had such a huge impact on the universe we see today.
So what kind of impact are we talking about? What did this super fast expansion actually do?
Well, for one thing, it explains why the universe looks so uniform on a large scale. If you look out into space, you see a pretty even distribution of galaxies everywhere.
Sure.
Without cosmic inflation, there wouldn't have been enough time for everything to mix and reach the same temperature.
So cosmic inflation basically evened things out, made the universe look the same in every direction.
Exactly. It's like smoothing out the wrinkles in a sheet. But that's not all. Cosmic inflation also helps explain how those big structures in the universe formed. The galaxies, the clusters of galaxies, all of that.
Wait, how did superfast expansion lead to all that structure? Wouldn't it have just spread everything out evenly, like a cosmic soup?
That's where it gets even weirder. We have to dive into quantum mechanics a little bit.
Yeah.
In the early universe, there were these tiny little variations in energy and density, basically random fluctuations.
But even though everything looked smooth, there were little differences in density.
Yep, tiny differences. And when the universe inflated, those tiny fluctuations got stretched out to huge sizes,
Oh, wow.
like taking a tiny speck of dust and blowing it up to the size of a mountain.
Okay, so the denser areas started pulling in more matter because of gravity.
Exactly. And over billions of years, they grew into the seeds for galaxies and all the cosmic structures we see today.
Wow, so those tiny little fluctuations are responsible for everything we see around us. Galaxies, stars, planets, even us.
Isn't that amazing? It shows how connected everything is. But let's get back to that expansion we were talking about. It didn't stop after inflation, and we know it's actually accelerating now.
Right, and you said there's this mysterious dark energy that seems to be driving it.
Exactly.
But we don't really know what dark energy is, right? So how did scientists even figure out that it exists in the first place?
Well, it's actually a pretty cool detective story. It starts with supernovae, those super bright explosions that happen when a star dies.
Okay, but how did exploding stars lead to the discovery of dark energy?
Well, there's a special type of supernova called a type Ia supernova, and astronomers love these because they all pretty much have the same brightness.
Like cosmic light bulbs with a set wattage?
Yeah, perfect analogy. Since we know how bright they actually are, we can figure out how far away they are by how bright they appear to us.
So the dimmer they look, the farther away they must be.
Exactly. And back in the late 90s, two different teams of astronomers were using these type Ia supernovae to measure the universe's expansion rate. And what they found was a total shock.
What did they find?
They found that these supernovae were dimmer than they should have been, which means they were farther away than expected given how fast we thought the universe was expanding.
So it was like the universe was expanding faster than anyone had realized.
Precisely. And the only way to explain this was if there was some unknown force counteracting gravity and pushing everything apart. That's what we now call dark energy.
It's like this cosmic tug of war going on. Gravity's pulling everything together, but dark energy is pushing everything apart, and dark energy seems to be winning.
Yeah, that's a great way to think about it. The expansion of the universe is accelerating, and galaxies are moving farther and farther apart all the time. It's a pretty big puzzle.
Definitely makes you wonder what's going to happen to the universe, right? If this dark energy keeps dominating, what's the ultimate fate of everything?
Well, one possibility is something called the Big Freeze. As the universe expands and cools, galaxies become more and more isolated. Eventually, even stars stop forming. The universe basically ends up as a cold, dark, empty place.
Sounds pretty bleak.
It's not the most cheerful scenario, I'll admit, but there are other possibilities too. Some theories suggest that dark energy might not be constant. Maybe it'll weaken over time, or even reverse its effect. That could lead to the universe collapsing back in on itself in what some call the Big Crunch.
So instead of fading away, the universe goes out with a bang.
Maybe. But for now, dark energy is a big mystery. We know it's there, but we don't know what it is or how it works.
It's humbling to think that this invisible force we don't even understand is shaping the fate of the entire universe.
Absolutely. And that sense of wonder and mystery is what makes cosmology so fascinating. We're constantly learning more, pushing the boundaries of what we know. There's so much more to discover.
I can't wait to see what we find out next. You mentioned earlier the possibility of other universes, and that the universe might be cyclical. Are those ideas as crazy as they sound?
Well, they might sound like science fiction, but they're actually based on some pretty intriguing physics. Let's dive into those ideas next. So we're back and ready to tackle some even bigger questions, like what came before the Big Bang?
Yeah, it's like we hit this cosmic wall. Our understanding of physics just can't go back any further.
Right. The Big Bang Theory does a great job of explaining what happened after the singularity, but it doesn't really tell us what caused it or if there was even anything before it.
So are there any theories that try to answer that question? What are scientists considering?
Well, there's this mind-blowing idea called the multiverse, where our universe is just one of many, maybe even an infinite number of universes all existing together.
Multiple universes. That sounds straight out of science fiction. Is
Yeah.
there any real scientific reason to think that could be true?
I know it sounds wild, but there are actually several different versions of the multiverse theory, and they come from different areas of physics. The main idea is that these universes could have totally different physical laws, different constants, different dimensions. It's pretty amazing to think about.
So, like, in another universe, gravity might work differently, or the speed of light could be slower. It's hard to even wrap my head around that.
It really stretches the imagination, and some physicists even think these universes could interact with each other, maybe collide, or even give birth to new
Well,
universes.
so our Big Bang could have been caused by a collision with another universe.
Yeah, it's a crazy thought, right? And it's one that could maybe explain some of the things we see in our universe, like those weird patterns in the cosmic microwave background radiation.
It's mind-blowing to think that everything we can see might be just one tiny bubble in an ocean of other universes. But what about other ideas? What else are scientists considering for what might have come before the Big Bang?
Well, there's another pretty interesting idea called the cyclical universe. This one suggests that the Big Bang wasn't a one-time event, but just part of an endless cycle of expansions and contractions.
So it's like the universe has a heartbeat, expanding, contracting, expanding again forever.
Exactly. The Big Bang leads to expansion, like what we're seeing now, but then eventually things slow down, reverse, and then everything collapses back in on itself in what some call the Big Crunch.
And then boom, another Big Bang kicks off a new cycle.
Yep, that's the idea. The universe just keeps going through these endless cycles of expansion and contraction. It's like a cosmic dance.
That really makes you think about time differently. What if instead of moving in a straight line, time is actually a circle, just repeating itself over and over?
It's a pretty profound idea. But we've covered so much ground already, from a tiny singularity to a universe that's constantly expanding and changing, shaped by forces we don't even understand, and now these incredible ideas about multiverses and cyclical time.
Definitely a lot to take in.
It is. And, the more we learn about the universe, the more we realize just how much we still don't know.
It's humbling, but it's also incredibly exciting.
I agree. There are so many mysteries out there still waiting to be uncovered. Who knows what incredible discoveries are just around the corner?
Well, I want to thank you for taking us on this incredible journey, from a tiny singularity to the vast, expanding universe we call home. We've explored the Big Bang, the evidence that supports it, and even pondered some truly mind-bending ideas about what might have come before and what the future holds. And for our listeners, I hope this deep dive has sparked your curiosity and given you a new appreciation for the incredible story of our universe. Keep looking up at the stars, keep asking questions, and never stop exploring the wonders of the cosmos.